So the first thing talks about a linear equation. So a linear equation is an algebraic equation. So an equation must have a what in it?
Variable.
Equation must have a
Equal sign.
Okay, so linear specifically deals with a relationship of variables, and it has to only go to a first degree. Do you guys remember the word degree? We talked about it during the exponential unit.
I don't remember that unit.
Okay, so here's an example that is linear. It's comparing x's and y's together, and it's a first degree because why? Exponent on x is only a 1.
And so then 2 exponent would be a second degree.
So now, is this a linear relationship or equation?
No.
No. Because this is a degree of 2. Okay? You're going to study that relationship in grade 11. And the name of that one is going to be called a quadratic relationship. And this is linear. Okay? Then when you get to 12, you also get to study cubics and quartics and quintics. Okay? And you have to graph them. That's all coming in your future. Okay. So a relationship to a first degree. Linear patterns increase consistently. So when you walk up a staircase, should those stairs be the same every time?
Yeah.
Okay, so that's linear. Okay, it's always doing a same increment change. Okay? In grade 10, you graph this relationship because equations can make graphs. Does anybody want to predict what kind of shape a linear relationship would create? A line. It's in the word. Linear. It makes a line. Okay? And when you increase on a line, are all the changes on a line consistently going? Yes, like a staircase. Okay, so this is what linear relationships look like. They have the same amount of change per, you have to make sure each chunk is the same as well though, right? So every time you're moving the same, you're changing the same. Move, change, move, change. Same pattern. Okay, so here we go. Describing the pattern. So what I'm going to do is get you to maybe, what do you want to do? Count the boxes first? Should we see if there's a pattern? Okay, so go one box. This pattern has 4 squares in it. What are we at now? 7.
You know what that reminds me of? Block blast.
Okay, so describing this pattern that each time you change the pattern and you go one further, what are you doing? Each pattern changes by adding 3 blocks then. Okay, so here we go. We're going to create a table of values. So in figure 1, we already kind of wrote this. We had 1 block, figure 2, 4, 7. Okay, so we have to make a linear relationship. Okay, so here I go. Blocks equals, so I have to do 3n because every time I was adding 3. So if you add 3 and then add 3, can that also be the same as doing 3 times 3?
Yes.
Does that make sense? Because here I added 3, added 3, added 3. That's also the same as 3 times 3, which is 9. Did that increase by 9? Yeah. Okay, so here's what I'm going to do to you. You ready? So how do we get to where we want to go? So let's take an example here. If we did 3 times n, so in this block, what is 3 times 3? 9. How are we going to get to 7 after that? Minus 2. Good. Let's check. Does that work? Ready? Let's try it here. If we were on the 4th figure, what's 3 times 4? 12. How do you get to 10? Minus 2. It works. Yeah. Okay, so how many squares, if we kept going in the pattern, how many squares would we have when we are at the 12th figure? So what should we do? What did you do?
3n or 3 times 12 subtract 2.
So you just followed this formula, and instead of writing an n, we are now saying n is 12. So it's a substitution. 36 minus 2 is 34. Okay, and this bottom one is a little bit trickier.
316.
So I have 106 blocks. So it's not, I'm trying to figure out the n number this time, right? Which figure? So that's the n. I'm trying to figure out the n, and I'm told I have 106 blocks. So what should I do with this formula? Where do you want to put 106? For the blocks. So I'm going to take the formula that I had and I'm going to replace blocks. Okay, so this time was where I replaced the n. And now here I replaced the blocks because that's the info I was given. Does that make sense? You have to read and figure out where you want to substitute things. Okay, this is what we just did. Solving. So what do you want to do? Add 2 and divide by 3. And does anybody have a number for that? 36th figure in the pattern. Okay, so that's the skills we just came from, which I'm promising you that unit that we just did is forever math. Everything involves equation solving. Yep.
Now I feel I've gotten higher.
You're only going to get better and better at it because you're just going to see it all the time.
I should have gotten 100%.
Okay, here we go. Figure numbers. So we have 1, 2, 3, 4 in the pattern. So those are the figures. And count the circles. So the first one has 1, 3, 5, 7. So then you're noticing something already? I increased by 2, I increased by 2, I increased by 2. Okay, so that's the pattern. Okay, so here I go. My variables are C and N. Okay, so the number of circles is, so we were changing by 2 on every figure. So 2N. Okay, so now let's figure out how to get where we want to. So here we go. I'm going to test. Doesn't matter. Ready? The 4. What's 2 times 4? 8. How can I get to 7 after that? -1. Okay, should we check it out to see if it works for another one? Let's go to 2. What's 2 times 2? 4. How do you get to 3? Subtract 1. It works.
Wow, that's simple.
Okay, how many circles are there in figure 71? So which letter is the 71 going to go for? The N. So I need you to write 2 times 71. You're replacing the N. Okay? So you can use your calculator. 2 times 71.
Why do you need your calculator?
142. I can't use my calculator anyway. Yep. Was that you?
No, but I know how you feel. Last year, someone in my class, they put it on the wrong way, and then they started hammering it.
I might be hammering this soon.
Yeah, it's the wrong way. It's supposed to go like this. I can try it off if you want.
Here's moving the test.
Okay, which figure, so that's my question mark, which figure would I be on when I have 83 circles? So this time, what did I do? I gave you the C value. So can you go to your equation, and this time you're going to replace C. So this time I replaced C. Does that make sense? Okay, so now this is algebra to solve. Solving equations. You have 2 moves. Which one are you going to do first? +1. And then divide by 2. So that means you're on the 42nd one. Okay, so this one's a little bit different in that row 1. Do you guys see this? This is row 1. Okay? So I need you to count how many beads there are. How about we divide and conquer? Hepzibah's row, you have the first row. Annika's row, I need you to count how many are in the second. Chloe's row, you have the third. And Kate's row, you guys have the fourth. Can you count them up?
There's 22. 22.
22.
So fast, you
Which row said 12?
Actually 22.
Yours is 12? 17? Row 1? 7. Okay, so that's the count. We divided tasks. Now we can share our info.
Are you actually being serious?
Okay, so somebody said, hey, there's a pattern.
Is it actually fast?
Looks like what's happening every time. +5. So if I say describe the pattern, what would you say?
fast.
Each time you add a row,
Add 5.
each time you add a row,
You just say add 5 to each row.
add 5 beads. Okay, so we're gonna make an equation. I need you to use these letters. You have to have an N and a B. An N for the number of row you're on and a B for the beads that are there. So what should I do? N equals or B equals? B equals. So we said, what's the pattern? It's changing by 5 each row. Okay, so let's
5n plus 2.
let's develop what we add extra or subtract extra. So ready? If I pick any row, so 2. What's 5 times 2? 10, but I got to get to 12. Plus 2. Does it work? Let's try 3. 5 times 3 is 15. Plus 2. Works.
How many beads are in row 4? 22.
How many beads are in row 4? So we already know the answer should be 22, but let's figure it out with algebra stuff. So 4, where should I put the 4? In the B spot or the N spot?
N.
N. So I'm going to put it into the N spot, and you evaluate. This is called evaluating because it's all on one side together. So that's just evaluate. What's 5 times 4? Plus 2, 22. And we knew the answer, so that's always good. How many beads are in row 38? So which letter should I be putting the 38 for, the B or the N?
N.
The N. So I replaced the 38 into the N position. Okay?
190, I'm pretty sure.
Did you add 2 to that though?
Yeah, 192.
192. Okay, if the bead pattern continues, which row will you have 92 beads? So 92, where should I put that? The B or the N spot? The B spot. So 92. So remember what you're doing. You're replacing the variable of your choice. Where does it belong? So 92 beads. Okay, now this is called equation solving. Okay, here this is called evaluate. Why am I just evaluating? Because the variable is alone. Why is this equation solving? Because the variable is not alone. Do you see a difference between those words? Evaluate and solve. So now you do your opposite process stuff. And what does that come to? 18. 18th row.
Oh, this one's about tofu. You're not done yet. I know. I'm a hungry kid.
Okay, let's look at the pattern. So we have a table. So this table seats 6 people. And now if you put the 2 tables together, we're not going to double it. Why?
Because
Why doesn't it double?
the outside, not
The side go.
yeah, that one. Yeah.
Because you're going to lose this end and you're going to lose that end. So So that's why you can't just double the people, right? Does that make sense? Okay, so let's go, what did we say, 10? Okay, do we want to draw it?
14 8, I'm pretty sure.
Let's draw it, but I think we could kind of do patterny stuff. Okay, so if we draw 3 tables, 1, 2, 3, 4, with a outside, right? So what are you guys getting? I got 5 people on the end,
I got 14.
and then I got 4 people on the middle table. So that made 14.
I got 14.1.
How are you
A,
gonna point
a
one person?
0.1 of a person or a chair? Okay, have you observed a pattern? Plus 4 people every time. Here's why. Because it's like adding a middle. And look at my middle table. I can only ever put 4 people at a middle table, right? Okay, so if I was to add another table to this, I'm going to get 18 people. Okay, so we're going to write an equation. Your equation has to contain a T and a P. So I'm going to talk to you now. I'm going to add in one word here. I'm going to talk to you about independent or dependent variables. Okay, what does the word independent mean to you in real life? On your own. On your own. Okay, you can handle things on your own. What does dependent mean to you in real life?
Separated.
You depend on people. Did you guys know that you're a dependent of your parents right now? You're a dependent. Like when I fill out my job and I have to do my insurance, they say, do you have any dependents? And then I have to list my children because they depend on me. Yeah. Okay, so here's what you always think of. So the independent is what depends on the other thing? Does the tables depend on the people, or do the people depend on the tables?
People depend on tables.
People depend on your tables. So people depend on what's happening. The people are independent, so they depend on the other stuff. Okay, so let's talk about the other stuff. We said that every time we have to do 4 and 4 and 4. So 4T.
Plus 2.
And then you have to go back to the pattern and figure out. So if I put it into the 4th and I did 4 times 4, 16. I gotta get to 18. It should work. It should work into any position. So if I do it into the first, 4 times 1, 4. To get to 6, add 2. Works every time. Okay. How many connected tables will you need to fit 26 people? So which letter is the replaced letter?
T. P, I mean.
P. Okay, so if you were to tell a person what to do, would you evaluate or would you solve? Does this make you evaluate something or does this make you solve something? Which one is this?
Evaluate.
Solve. Evaluate is just collect numbers together. Solve means do your algebra teeter-totter stuff to get something alone. Okay? Those words are different. Okay, you guys are pros now at these 2-steppers. Minus and divide. So what do I know? I'm going to have to put 6 tables together.